In this video, we're going to go over the first part of our notes on operations on rational expressions. The first thing we're going to learn is simplifying rational expressions. There is one note sheet for this entire unit, so you can see the other boxes, multiplying, dividing, and then adding and subtracting. Those will be other days. So let's get into the simplifying rational expressions portion. I'm going to type it out into this box. It's going to be relatively small, but you can fit yours in by writing it just as well. So when we simplify rational expressions, it's important to know what simplest form actually means. So simplest form means there are no common factors on the top and bottom. So you can say denominator, numerator, but that's what simplest form essentially means, is that we don't have common factors. So we'll get a little bit more into the specifics of what common factors are. Our second note in this box is that we are going to follow the exponent rules. We learned those in previous units and in previous courses, but it's things like when you multiply bases, the exponents add. We're going to follow those rules. And then we're also going to always factor our polynomials. I always spell polynomials wrong. There we go. Next thing we are always going to make sure we do, and this is a really big one, people tend to get caught up on this, is that you can only cancel factors. Do not cancel terms. This is the biggest error when simplifying rational expressions, so please make sure that you are always paying attention to what you're actually canceling. A term is something that is like an X or a 5. Those are terms. When they're by themselves, they can be crossed out using our exponent rules, but when you have an X plus 5, that makes it into a factor. An X plus 5 can only get crossed out from another X plus 5. You can't cancel out X plus 3 and X plus 5 because they both have X's. They have to match exactly in terms of the factors, not just the terms. Now, since I've mentioned this idea of canceling several times, let's actually define or talk about what helps us cancel things. So identical factors, those are the things that we want to cancel out. When they're shared between the top and bottom, or the numerator and the denominator, they cancel because they equal 1. Identical factors on the top and bottom cancel because they're equal to 1. Similarly, opposite factors shared on the top and bottom, numerator and denominator, can be replaced by a negative 1. Let me get my window a little bit better here. There we go. Opposite factors on the top and bottom can be replaced by a negative 1. So what that means, when you have identical factors on the top and bottom, you get a positive 1. So if you had a 2 on top and a 2 on the bottom, those go away and just are replaced by 1. 1's kind of a placeholder in math. If they're the opposite, so for instance, the opposite of 2 is negative 2. If you have a 2 on top and a negative 2 on the bottom, you would get rid of both of them and replace that with a negative 1. So just one negative 1 will replace both of those factors there. So that's the reasoning or kind of the explanation behind what we're actually doing mathematically. The last note that we're going to put in the box is something that's always important throughout this entire unit. So this will be something that we write in a lot of different boxes, but you always need to factor first. But always, 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 always make sure you factor first when you are simplifying rational expressions. So simplest form means that there's no common factors on the top and the bottom. We always follow the exponent rules, and we always factor polynomials. We're going to do that first. You can only cancel factors, not terms. The identical factors shared between the top and the bottom cancel because they equal 1. opposite factors shared on the top and the bottom can be replaced by -1, and then just once again, always factor first. So now that we've talked a little bit, let's get into some actual problems that we would like to practice here.